Smart Coffee is highly customizable software that runs on an Arduino or similar microcontroller. It replaces the factory Espresso machine controller and enhances your Espresso machine with new features, such as an OLED display that shows several parameters, which can be displayed in both metric or imperial units. Using the brew lever activates the pump as normal. However, when Espresso mode is on, the machine runs through a completely customizable pre-infusion cycle. Additionally, the pump automatically turns off at a programmable shot timer or dispensed volume of water. This enables you to pull fairly consistent espresso shots without using a set of scales every time. I achieved accuracy within plus or minus 1 gram of my target. Although this isn't technically perfect, it is more consistent than I can manage using a set of scales and manually stopping extraction. I pulled 6 shots back to back using Espresso mode with a target of 38 grams of water. My average Espresso shot weight worked out to be 38.2 grams across all 6 shots. If your machine uses a water reservoir, you can fit a sensor that measures the water level, which is then printed on the display. Once the water level drops below a certain level, the pump and heating element are automatically disabled until the reservoir is refilled. Alternatively, you have the option to use a touch-sensitive reservoir probe or reservoir switch, depending on your preference or type of machine. Smart Coffee uses PID logic to control the boiler pressure, providing you with faster response and improved stability. You can tune your PID or PWM settings and program your target pressure to suit almost any machine. You also have the option to add a temperature sensor, which can use several different types of probes to monitor almost any temperature on the machine. With an Arduino on board, we can add little nice-to-have details, such as pausing a boiler refill during an espresso shot. Once the brew lever is off, the boiler can refill automatically if required. Safety is also a high priority for Smart Coffee. You can program the minimum and maximum pressures, and optionally minimum and maximum temperatures to trigger safe mode. Once safe mode is triggered, the machine shuts down and won't operate the pump or heating element until it is reset by the user and the error is cleared. This nicely complements the other factory-fitted safety hardware found on most espresso machines. What's involved in fitting Smart Coffee to a machine? The factory controller is replaced with an Arduino Mega Pro or similar microcontroller that is running Smart Coffee software. From here you can customize the software to merely replace the factory controller's functions, or you can add any combination of extra features and sensors, such as a flowmeter, temperature sensor, ultrasonic sensor, espresso mode, and much more. The Smart Coffee software comes with a detailed guide that describes each setting and function. It has been designed from the ground up to be easy to set up. However, to use Smart Coffee with my Rocket E61 espresso machine involved more than just software. It involved wiring in extra sensors, fitting new hardware, and calibrating the sensors. How much is all the hardware? If you opt to fit every available sensor and option like I have on my Rocket Coffee machine, the total hardware cost is around $150 US at the time of making this video. You can find a complete list of all the hardware by checking out the forum page for Smart Coffee. How much is Smart Coffee software? You can buy Smart Coffee software for 16 New Zealand dollars. That's about 10 US dollars at the time making this video. It's available from the Schematix online store. You'll also find free STL files to print a mount for the display, or optionally you can buy a pre-printed display mount from the store. What espresso machines are compatible with Smart Coffee? Smart Coffee has been designed to be highly customizable to suit many espresso machines. At the time of making this video, it's compatible with most single boiler, aka heat exchange coffee machines. However, check the forum page in the description for updates and compatibility. Are there planned future updates for Smart Coffee? Yes, there are plans to update the software with more options and wider compatibility to include more machines such as dual boilers. We'd also love to receive suggestions from the coffee community to further the development of Smart Coffee. Check out the official Smart Coffee forum page for the most up-to-date information. So with that done, let's start right back at the beginning of this journey. Once upon a time, in a land far, far away, sometimes called the land down under, there was a fella with a broken coffee machine. He was very sad. So, this is my E61 Rocket coffee machine, and at present, it's broken. The factory controller, which handles things like turning the water pump on and off to do things like refill the boiler, is broken. And weirdly, it's obnoxiously expensive to replace. So I had the idea, well, why don't we replace the factory controller with an Arduino, write some code, and be cheaper? And yes, that is possible. However, I quickly realized that with the addition of an Arduino, we can add so many more features than this coffee machine was ever intended to have. Let's dive in. First on my to-do list was to remove the panels to gain access to the internal hardware. Here is the factory controller that I'll be replacing with my Arduino. The factory pressure switch will also be replaced with a pressure transducer. The Arduino will have to interface with some of the factory hardware, such as the boiler probe to detect the water level inside the boiler. I'll also keep the thermal fuse since it's an important safety feature. My next job was to remove the factory wiring and controller. Then I replaced the pressure switch with my pressure transducer. I had to use a BSP to GICAR adapter to fit my transducer. I'll leave a link to purchase thread adapters in the description and on the forum page. Next, I grabbed a piece of alloy sheet to make a mount for the relays and power supply. The mechanical relays shown here were later swapped out for solid-state relays, which are better suited for faster switching. This was a necessary upgrade when I introduced the pre-infusion cycle for Espresso mode. Rivet nuts are super handy for projects like this, adding robust threads to thin sheet metal. To protect the Arduino and electronics, I mounted a plastic enclosure to the chassis of my coffee machine. A panel-mounted USB header is connected to the Arduino, which allows me to connect to it without removing the side panel of my coffee machine. I've drawn a wiring diagram to connect all the hardware to the Arduino, which you can find on the forum page. Next, I crimped DuPont terminals onto the wires so that I can connect them to the Arduino. Since the Arduino is receiving several analog signals, it's very important to use a shielded cable to prevent electrical interference. With shielded cable, you'll typically find an outside wrap of wire strands, or in my case, alloy foil with bare wire. At one end of the cable, the foil and wire are trimmed flush with the insulation. At the other end, I trimmed the foil flush and then connected the bare wire to ground from my power supply. The shielding should only be connected to ground at one end. Doing so prevents the current from using the shielding as a current path. When it comes to flow meters, there are two options in Smart Coffee. They are single or dual flow meter configurations. Let me quickly explain why we have these two options. Over here we have the water intake tube that sits inside the water reservoir. Water gets sucked up by the water pump, goes through the pump, gets pressurized, and then feeds the coffee machine, and it does things like push water through the heat exchanger, which brews our coffee. Now, if we want to calculate how much water flows through the system, we need a flow meter like this one. Now, this is a low pressure flow meter, so we could put it over here on the inlet of the water pump to measure how much water gets sucked up through the tube. However, we won't know how much water goes through the heat exchange because some of the water that gets sucked up gets returned back to the water reservoir. And it gets returned through these two valves here, which are used to regulate the pressure in the system. And they bleed off some water to keep the pressure at a constant. So that is a problem. Now, we could hypothetically buy a expensive high pressure flow meter and fit it somewhere after the valves have bled off any water, and that way we know how much water's gone through the heat exchange. However, high pressure flow meters are expensive, and we've also got to now buy custom adapters and fittings and maybe bend some hardline tube. It's expensive and it's more difficult. So there is another way. What we can do is use two flow meters. We can put a cheap low pressure flow meter measuring how much water goes into the system. We can use another cheap low pressure flow meter on the return tube that goes back to the water reservoir. We measure how much water goes in over here. We subtract any amount of water that's returned to the water reservoir from this sensor, and then that remaining amount of water we know has to have gone through the heat exchange and brewed our coffee. Now, if dual flow meters aren't your thing, perhaps you only want to use one, or maybe you want to fit a high pressure one, there is that option in the code. You can simply enable a single flow meter and use that to calculate how much water has gone through the system. No problems there. Flow meters come in many sizes and specifications. I've opted to use a small precision flow meter on the return line since the water flow is minimal. For the pre-pump flow meter, I've chosen a larger unit that is rated to match the flow of the pump. With the flow meters fitted, I moved on to wiring up the relays. All the solid state relays will switch the neutral line. This is because in the event of a relay failing, the heatsink or circuit of the relay won't become live. On my 5V power supply, I reference ground to earth. This is done so that the shielded cable is properly grounded, and this also improves detecting the water level inside the boiler. Now I can connect the brew switch, boiler probe, and boiler refill valve. Even though Smart Coffee has safe mode for overpressure and temperature, I kept the factory thermal fuse since it's a great safety backup in the event the Arduino has a brain fart. To mount the Espresso mode switch, I drilled a hole in one of the side panels. In order to mount the OLED display, I resin printed 2 different styles of mounts along with mounting templates. You can download the STL files from the forum page. After a coat of paint, it was time to choose a mounting location. I used the template to mark and drill the holes. Next, I cut a piece of 2mm acrylic to protect the screen. I used M2 button screws to mount the acrylic and OLED screen. Later on, I have plans to use the temperature probe to monitor the group head temperature. However, I don't have the correct hardware to mount it, so for now I'll just use Kapton tape to fix the probe to the outside of the boiler. With all the wiring done, I can move on to setting up the software. There are dedicated videos for calibrating sensors and setting up Smart Coffee. To keep this video to a reasonable length, I'll give a brief overview of the setup and calibration process. First, I had to calibrate the boiler probe to detect water. I backed off the compression ring, which allows me to slide the probe up and down. I connected the Arduino to my PC and opened Smart Coffee software in Arduino IDE. First, I made sure the heating element and pump relays were disabled. Next, I enabled serial printing. I then opened the serial monitor to observe the boiler probe value. With the probe raised above the water level, the capacitance value is around 200. When I lower the probe into the water, the value jumps up to over 800. With these figures in mind, now I can set my threshold value that triggers a boiler refill. With that done, I can now verify that my threshold value is working by moving the probe and seeing if the Arduino triggers a refill, which it is. Now I can retighten the compression ring. Next, I updated the default pressure transducer values so the Arduino can accurately interpret the signal from the transducer into pressure. With that done, I can start to reinstall the panels. The ultrasonic sensor has an inline connector so I can remove the reservoir lid when required. With the hardware finished, it's time to set up the remaining software settings. Next on my agenda was calibrating the flow meters. This involves dispensing water, measuring it on a set of scales, and then tweaking the pulses per mil value until the Arduino is accurately dispensing the desired amount of water. Calibrating dual flow meters is quite time consuming to get right. If I was doing this all over, I'd rather pay more for a single high pressure flow meter, which would be much quicker to calibrate. Having said that, I'm happy with the accuracy I was able to achieve with my dual flow meter configuration. So having options for both single and dual flow meter configurations is useful for the end user. From here, the rest of the features are pretty straightforward to set up. First, I enabled the ultrasonic sensor, and then enabled the option to turn off the element and pump when the water reservoir level is low. With the reservoir tank reinstalled, I measured the bottom of the tank using a ruler, which is around 250 mm from the lid. Then I measured the distance between the face of the sensor and the water level when the tank would be full. In my case, it's 30 mm. Now I enter these values into my Smart Coffee software. You can also customize the water level percentage that triggers a refill state. Up next, I enabled the temp sensor. I'm also opting to use the temp sensor as a safety feature, which gives me the option to program min and max temperatures to trigger safe mode. Now I can choose to use PID or PWM logic to control the boiler pressure. There's a dedicated video on this process, however here's a quick overview. Since my machine features a relatively large boiler, it has slow response and high inertia when it comes to maintaining pressure. I tried many combinations of PID values, and while I did achieve good results, I achieved more stability and faster response using PWM logic. Smart Coffee offers both PID and PWM options for controlling boiler pressure, depending on user preference and the machine. Now my rocket machine is better than ever before, and it's ready to make the best espresso it's ever produced. I thought my favourite feature would be the espresso shot mode. However, after using the machine for quite a while, my favourite feature is actually the display information. I know exactly what my machine is doing at any given time, and not having to constantly check the reservoir level is a true quality of life upgrade. Don't forget to check out the links in the description for the most up-to-date information and software updates, and I'll see you in the next video, probably on a caffeine high. See you next time.